Today's session is all about fire stopping in Solibri Office. I'm Ken and Simon's going to be doing the main part of the live demonstration itself. So I don't know if Simon wants to say hello or we'll just carry on.
Hi everybody, thanks.
Dropped a minute there. Okay, so we're going to do a little bit of PowerPoint first and then get into the main demonstration part itself. So we'll try and keep this as brief as possible. So quick look, we are looking at fire stopping in Solibri Office. It is Solibri Office we're looking at. We'll talk about the family in a second. Quick run through some background first, just about Solibri the company, the product family, typical workflow, and then focusing on the solutions that we're developing and specifically the fire stopping stuff that we're going to be looking at today, and we'll talk about how that's going to be released, etc, towards the end of the session. The main part though is the live demonstration, which Simon will do, so we'll get to that as soon as we can. And as I say, there is a Q&A at the very end of the session just to pick up anything that's you want to ask. So just a little bit of background about Solibri. For those of you who don't know, Solibri is all about quality checking of models and producing better quality digital models for the construction industry. We deal predominantly with IFCs, and again, we'll get into that in a little bit. We have been called the spell checker for BIM because essentially we have a bunch of rules that we use algorithms behind that we go and look for particular problems within these digital models. In terms of the background of the company, Solibri, the main company that started it all off way back last century, is based in Helsinki. We became part of the Nemetschek group in 2015, and specifically the UK here, we became a full-on subsidiary in 2016, although we existed as an entity before then. But our head office is Helsinki, our UK office is Leeds, and as you'll probably be able to tell from our accents, myself and Simon, we're not from Yorkshire, but we are dotted about as an organisation all over the place. Some of the basic stats just to talk about. We're on track for an estimated 14 million hours usage of Solibri Office this year, and we know from because we use a cloud licensing system, etc. We know from those statistics as well that the software is in use in 133 countries, and we're estimating something like 50 million checks to be carried out. So there's some fairly big numbers. In terms of the product family, we talk about Solibri. There is only one piece of software called Solibri. The license that you have, whether it's a subscription, a solo, a Teams, a network license, whatever it is, that determines what you can actually use, whether that's Solibri Office, Solibri Site, or if it's the viewer, which is just the Anywhere product. Today, because of what we're going to be looking at, we're specifically focusing on how we check models and how we customize rules, again, specifically for the fire stopping process. So for that, it is Solibri Office that we are talking about. Just to set the scene of where this sits in the workflow, typical workflow in Solibri always starts with IFC, and typically what we do is we bring those together, usually multiple IFCs to combine and create a federated model. That creates our SMC project, and then the key stages here are we can take that project, we then organize it into the way we want it to be, whether that's through classifications or just physically coordinating the models in different ways. But what we come on to from that point is checking. We check what's in the model, and this is where we'll be focused today on the whole fire stopping side of things. So we want to identify any problems, decide what's going to be done with them, and then pass them on. Once we have a reliable model, then we can talk about information takeoff and how we can take data from the model. That's not really what we're looking at today, but the final stage is once we have checked the model and identified any issues, we have to communicate those. So we need to share those with others, and typically what we're trying to do is do that with BCF. So BCF's BIM collaboration format. From there, it's an open source format. The beauty of that is we can plug straight into most of the common authoring tools. That means we can quite quickly get some updated models returned, which plug back into the system and give us a nice closed loop so we can repeat this process, because we don't just do it once and have a finished model and everything's perfect. sadly, as I'm sure many of you will have experienced. As I said though, today we are focused on this area here, which is the checking part of the process. So coming now on to the more specific stuff, which is the whole solutions and the fire stopping side of things, we have developed an entity, a team, a project, whatever we want to call it, but in the UK we are looking at providing bespoke solutions. So we have our own development team and we've partnered with strategic industry partners to create tailored solutions for Solibri, and these can be simple things like just checking names conform to ISO 19650, to creating custom checks that do things like one of it's the very first solution that we'll release is the stud opening check, which actually creates pseudo components to check things that just are not possible in the normal sense because components aren't actually modeled. So we can do some quite detailed stuff like that, right up to complete projects such as this fire stopping project we're looking at here. So these solutions are going to be free to customers with a valid maintenance agreement, and they're developed primarily for the UK, but they can still be used elsewhere with a little bit of tweaking for localized standards, etc. What we're looking at today, the fire stopping side of things, is part of our BIM Coordination Plus library. The solutions we're developing fall into these 5 main headings that are appearing on just now. So BIM Coordination Plus, the first couple of items we'll release will be part of this library, but then we're looking at others that are discipline specific or the generic. Regulations or standards, so stuff like the ISO 19650, and then also sustainability. Today's stuff, for fire stopping, we have developed a whole bunch of resources that includes 10 completely new rule templates. So if anybody's used to the rule set manager, there's a whole new category will appear in there called BIM Coordination Plus, and as part of that will be fire stopping and this whole bunch of rules here. So I'm not going into any more detail on that just now because Simon's going to show that properly within the software itself. But as a side note to that, if you guys are going to be using any of these resources, we'd highly recommend that you take a look at the rules tutorials that we created last year. They are on our website. There's a QR code in the link, and we can send this out afterwards if anybody wants to have it as well. But that goes through the whole process of how you create, you customize, you manage custom rules. So if you're going to be doing anything with those rules, it is well worth taking a look through those resources there. They're available as text, and also there's a bunch of movies behind them as well that go through the process. Back to the fire stopping side of things as part of our BIM Coordination Plus. These are just some examples of the sort of things we can do. So this is what we're actually looking at. You can see that we have the fire stopping rule set. The results have been organised in a particular way. I'll come back onto that in a second. But this example we're looking at here, we have looks like a ladder. It's a cable tray for those of you in the know. And if we look a little bit closer, what we can see is that that cable tray is actually too close to the edge of the opening that's passing through. If we look at the info itself, what we've done is format this up in a nice presentable way, hopefully to make it nice and clear to read and understand what the actual problem is there, and then this can obviously be reported off the back as well. Some other examples, again, you'll see we've broken these down and organised them by the fire seal instance ID, and what we can then do again is present the various bits of info at the bottom. Simon will go into more detail on that. And what we've also tried to do in this example here is just group them together by this, again, fire seal instance ID, just to try and give a logical approach to how we actually present that information. So you can see all 3 issues are grouped into the one item to make it easier to report and move on from there. But enough about me. What I'll do now is pass over the screen to Simon, and he's going to do the live demonstration and carry on from there. So bear with me. We'll just make Simon presenter.
Okay.
There goes. We can see you and I can hear you. So I'll mute myself
Brilliant.
and over to you.
Okay, thank you, Ken. So what we're going to do now is look at the functionality that we've created. It's been developed as part of collaboration with some of our key users, but generally speaking, the definition of it has been based around sort of the fire stopping of service penetrations by the Association for Specialist Fire Protection here. And what we've been concentrating on is really the Golden Rule 4. Which is all about the spatial sort of functionality to do with the checking of it. So it's looking at this key area here, which is analyzing basically all the supporting construction, the positions of and the sizes of the penetration seals, the proximity to each other, the positions of the surfaces within those seals themselves, with either to the actual seal itself or to each other, basically. So they're the kind of functionality that we've been concentrating on. So what I'll do now is I'll just close down the Acrobat Reader here. What we'll do is go into Solibri. I've just set up a role with my fire stopping rule set, and I've got a couple of classifications that are used within the solution. So in here, I'm just going to open up my three models. So the architectural model, a mechanical model, and a structural model. We'll open those up, and as good practice, as we always do, we'll give those short names so we can understand when we receive any kind of issues, we can see what components are from which models. And again, I'll set those disciplines up so that the rules can actually find the data correctly. So that's just something relatively simple. So the model itself, just a very, very basic sort of outline of a few walls, basically with some surfaces going through them. If we go to the information takeoff tab, first of all, where the classification generally is found in the Solibri interface, we have two classifications which primarily drive the fire stopping solution. Now, in this example, they are very generic, but in real life scenarios, they will be a little bit more granular. So when we look at the fire seal classifications here, we can see we've got fire seals 1 and 2, and we've just done this by position within the wall. But realistically, these fire seals will be, at an early stage, they might just be the BWICs. They, at the later stages, they may be standard test condition IDs, such as for manufacturers like Rockwall and Hilti and those types of people. So I wouldn't expect to see Fire Seal 1 and 2 in here. I'd expect to see things like RW, whatever it is, SW145, whatever, which would be the standard detailing function for a particular condition. So in this situation now, I'm just going to classify one of them slightly differently, this one here, and I'm just going to set this up so that we've got a Fire Seal 3 as well. So all I'm doing here is, let me just grab that a second. Classified components, there we go. So we'll set this one just to Fire Seal 3. So now we've got these different sort of classifications of fire seals. Now, on top of that there, so this controls basically the actual fire seals or the BWICs in the model, or the openings. So basically we can run the vast majority of these rules based upon different stages of the project, and I'll come to that with the rules themselves. The other part of it is a service classification, and again, must stress here that what you would expect to see down here is a categorization of things like copper pipes that are, plastic pipes less than 160 mil or that type of thing. So you'll use within the classification the relevant fields in here, so such as the diameters of pipe diameters, things like that, in order to actually then classify the types of components how you'd expect them to be, so that when we're looking at the fire seal standard sort of details, we can then apply that through to the types of services as well. In this case here, it's just showing the functionality, but you would break that down to a much higher degree of granularity. So once we've got those two bits of data there, what we've got in our checking area is a whole host of rules here, which enable us to step through sort of the types of checks that you might want to carry out when we're analysing the fire stopping within a building. The first one is really the identity rule, and the whole purpose of the identity rule is to identify where we have penetrations through compartmentation walls and floors. So let's run the check at the moment. So we'll run the check and let it go away and do its thing. When we click on the identity rule, what the identity rule does is it goes through and actually you have to specify with the identity rule what are the walls and the floors, which are compartmentation walls and floors. And then what we can do then is we can specify, I've got a value here, which is floor distance, and I'll explain this in a minute. And then we can then specify the to include any of the fire stopping services. And then I've just put here is defined. So anything that we've classified, I'm now using within this rule. So relatively simple sort of filters really that are used within Solibri. The floor distance is so that if we have panelized systems or elements that might have pseudo holes in them. So for instance, if you're modeling in Revit and you had a panelized floor system and you punched a hole in it using editing the objects, you'll find that there's no physical voids there. As in, there's a physical void, but there's not an object, which is a void object that which clash with. So there's no physical clash between those elements. So what we do is we would look at those panelized systems, and if they're grouped together or they're butted or and there's gaps between them where the services might go through or cutouts, then what we'll do is we'll look for a distance for another part of the floor, and then we generate a pseudo object and then check whether the services penetrate through that. So we've done a lot of work here to make sure that we don't miss any services. That's the key thing. Now the rule itself, the outcome of the rule basically then shows by level the number of penetrations per wall type. So you see as we click on these walls, it's showing us how many of these penetrations. So we've got 3 in this one, we've got 3 in that one, 4 in this wall, 16 in this one, and so on and so forth. And when we get down to the slabs, you can see that we've got 3 in that one there. You can see you can individually go into each of these items if you want to. The key part about this is if we go back to this one with wall with 16 sort of items in it, is that we've also tried to keep the position of these relative to each of the services. So what we don't want to do is that each one of these issues, we don't want to click on them and find they jump from one side of the wall to the other. And if we're planning BWICs in a model, then we might want to start looking at these for grouping them. So for instance, you can see it steps through the wall based upon its X position. So we're getting a little bit more logical sort of breakdown for those. So if, for instance, we've got these 2 pipes here and we wanted to create a BWIC for it as an instruction, then at that point there, we could collate those 2 together and actually then say these ones, we need to put a BWIC around them for planning purposes. Now, bear in mind that this rule has another option to it, which is checking for fire seal coverage. So this could be checking that you've either got a BWIC that's assigned to these services, or it could be the physical opening that's been actually punched into the walls or floors, or it could be the actual fire stopping component that we might want to check. So at each stage, we could then go and check whether or not there is a definition of those components in the model. So for instance here, in the next version of the model with just that item tick. So all I've done here is tick the box and then specified the fire seals from that classification, so all of them. What that does then is it gives you the same list of data, and if we go back to that same wall with the 16 issues in it, you'll see that the ones that are the yellow sort of issues are basically saying so it's indicating, so it's not really a failure, it's indicating to us that we're okay with these, and you can see that the blue objects are the actual fire seal components so it has been addressed. So each one of these have been addressed. Whereas if we go to the top one here, you'll see that we don't have a blue object there, which is the fire seal component. So the idea is with this is it's ensuring that not only have we identified all of the penetrations within the compartmentation walls, but also that we've addressed them with components to make sure that they are actually being looked at. So that's really the identity rule, really. So that's our first rule. So although we've got 2 here, it is the same rule. It's just with the option checked to actually check whether or not we have actually addressed those issues. And again, we can use those at different stages of the project, which is useful. Then we move on to the other rules in this list here, and the other rules in the list actually use a Excel spreadsheet to drive the functionality. So the Excel spreadsheet in the background can be used to externally to set up and then drive the actual results inside Solibri. So if I go to my Excel sheet here, we are using, so if we look at this service distance here, what we're doing here is we're looking at this this general distance rule, our general distance rule. The rule basically says go and check the walls and slabs. Again, we'd have to specify they are the fire compartmentation ones, not in this case here, we're just checking all walls. But this is just standard filtering functionality that you must configure inside Solibri. Then we would then specify the services again, and then down here we put the service classification in, and then the requirements file path. The requirements file path then points at this Excel spreadsheet, and in this case here we can then put in our services, and then we can then specify the distance to the same service. I've just put 300 in here. We wouldn't normally use 300, but it just shows the process here. And then you can then do a distance with a different service type, so not the same service type as what we're specifying. So we can do that. Now the issue category is used within the rule outcome as well, within the rule results as the categories. And you'll see that in the results area. So when we run that rule there, what we've now got is these generic service distance sort of checks. So this is really sort of very basic. Make sure that we haven't got sort of certain elements within a certain distance of each other, you know, that might cause us problems later on down the line. So it's a very granular sort of check here, a very outline stage where we might not have BWICs in there or anything else. It's just saying, you know, just give us some kind of idea of any kind of problems. Now you notice it's using generic service distance. And when we double click on it, it takes us to those relevant components and then measures the distances between them wherever it doesn't conform to it. Now again, down here, it will specify the service type 1 and 2, and it then sets the maximum distance and tells you what you've actually got here. So again, what we're trying to do with all the rule results is try to make them clear so that if we create an issue, we add an issue to it, what we get in the actual description is basically that information. So we don't have to then start creating any of that data manually within the rules. And later on, when we have the IDs for the penetration IDs for the fire seals, then we will use the ID for the components to list the data. So that's the general distance rule here. That again, it just literally just goes away and actually checks the distances between certain service components, and again it will do that across the board, relevant to whatever we got selected. Now the compatibility rule, which is the next one, really it looks at the service compatibility here. So it needs to have a fire seal or an opening or something that's been defined. And what we're doing, because obviously we're checking the services that are going through a singular fire seal here, and the whole idea is it might be that you don't allow dampers to be in with any other type of material in this case here, or a different type of service. So in this case here, we've got some wildcards that we use in the spreadsheet. So first of all, we have the service, and then we have the compatible service types. So if we don't put a value in, then basically it must be on its own. Okay, if we put a value in, and then we can specify a functionality saying that ducts can only have other ducts with them, and then what you do is you put semicolons in between them, and obviously a star is the same as anything else inside Solibri, as in it's a wildcard for any object, and then there's a double dash, which is double hyphen, which is anything but. So this is like so I can have ducts but nothing else, if that makes sense. And then if we do pipes and then put a star, then generally speaking here, it was saying that pipes can be put in with anything. So it's again, the idea is for you to spot where you may have actual problems in the model. So we've got incompatible service types, where basically we've got a cable carrier special with cable carriers, and then we've got a singular service type, which is, as you see here, the cable carrier must be on its own, because in our spreadsheet we didn't put a value in at the top here. So what we can do is actually at least highlight where we might have incompatible services with each other going through the same fire seal itself. So again, very, very quick rules in order for you to actually identify some very basic fundamental things that shouldn't actually happen. Then we move on to really the crux of the rule, which is our distance rule. The distance rule here uses 3 tabs on this spreadsheet. So the first one is the fire seal distances. So what this is saying is, so we've just put fire seal star in here. So what we're saying is any of the fire seals. You could just put a star in there and it would do all of it. And then we're saying each fire seal must be 300 millimeters away from each other. And we've got the fire seal distance as the category value for it. So you can put your own category values in, and it will then change what's going on in the results. On top of that, this rule also checks the again within the same fire seal. It then looks at the allowed service types that you're putting in there. So, for instance, in here, you can actually again say that this particular fire seal, if this was a manufacturer's detail test condition, you can actually put the test condition in, specify the types of services that should be allowed in there, and then the distance from those services to the actual edges of the fire seal itself. So to the aperture of it, basically. So we've got a minimum, we've got a maximum value as well, which can be used to make sure that we're not too much distance around, say, circular pipes where they're in a single opening, so a circular opening. And again, we've named this service to aperture. And then finally, we've got service distance in the fire seal itself. And this is concentrated on the services themselves against other services. So again, you've got which seal it's in, the type of seal it is. You've got the source service type, and then you've got a target service type. And then on top of that, then you've got your minimum maximum. And this is a fire seal service to service check. So the idea with these 3 tabs is that when we run the rule then, so the rule basically gets set up, and again, the compartmentation is set up, the services are defined. We're defining these from the service classification. We have our fire seals here. We have the fire seal classification, which is referencing that. And then because now we're using fire seals or BWICs or whatever, then what we can do is we can put the ID in. So we categorize the results by the ID. So what we're now looking at is the fire stopping penetration ID in this case here. And that means that when we run the rules, the results will be categorized by those fire stopping penetration IDs. So if we go and have a look at this kind of condition, first of all, you'll notice that we got a fire stopping penetration ID of FSW006, for instance. And what it's actually showing here is the distance between 6 and 7 here, between these two, doesn't conform to the 300 mil that we actually require between the fire seals. And on top of that, then it's also got another issue to do with that one fire seal here. So there's 2 issues to do this one fire seal that's saying these are not fully within the fire seal itself. So we're checking the full compatibility of whether or not they physically go through the fire seal. Again, because we have the next fire seal, which is number 7, which is part of the same issue, you'll notice that with this one here, when we select this one, it also highlights the issue above it. So if we create an issue at this level here, it creates it for both of those. So we don't have to then go and find the same issue twice. If you've already created an issue for that condition between these two, it recognizes it within the rules. So we're trying to be as intelligent as possible with not only the categorization, but the way that the rules actually work as well. And again, we've got this fire seal distance to this other fire seal. And again, we've got, in this case here, we've got services that are not allowed in this fire seal. So this was fire seal 3. And in our definition here, we said that in fire seal, we've got to have pipes in here. And you can see we've got cable trays, cable ladders. And obviously, they're not allowed within that. So it's telling us these are not allowed within the fire seal itself. So again, it's breaking it down per fire seal as far as the types of issues that we've got in here. And again, service to service distances, you can see here, are catered for, as well as the distance between the fire seals. And if we go down to the example that we saw earlier, let's just go down to, let's take this one here. You'll see that we've got this cable ladder here, and you can see that if we select it, it's telling us that the fire seal ID is 009. The type of fire seal is fire seal 2, so this would be our manufacturer's ID. We'd say that the cable carrier is going through it. The minimum distance to the edge is 50 mil. We haven't put a maximum in, so it goes to infinity. And then you've got an actual distance here, which is 27.5. So you can see it's actually measuring it to the edge of that fire seal component. So that's the way that like our distance rule works. And then we can then sort of look at some of the other kind of functionality that's here. So if we look at the dimension rule, the dimension rule looks at the fire seal dimensions. So this is like looking at manufacturer information as far as minimum, maximum sizes of, say, the ablative bats and that type of thing. So height and width sort of dimensions of these kind of components. So this will then tell us whether or not they conform to the size requirements of the requirements we put in the spreadsheet. So again, relatively simple. Sort of, it's just looking at the component that we've got that classified against that set of requirements. So moving on, really, then we're then moving on to the position rule. The position rule here has a little bit more complexity to it. So what we have here is we have the walls and the floors, we have the fire seals that are there, and then we also have the fire seal ID, but then we have obstructions in here. Now the obstructions really are for, so what we're doing with the position rule is we're checking the manufacturer's sort of position within a wall component or a floor component where it's deemed to be approved by the manufacturers, how it sits in the wall. Now this is using this position in the walls tab. Again, we have our fire seals, and then we can actually set the distance to the side compartmentation, so we can have a minimum and an offset from that as well. And then we can do also a distance to the top compartmentation. So if I've put in 400 here just to, if we put 300 in, we'd end up with it would pass it. So, but the whole idea with the top compartmentation is that this fire seal here, as a manufactured sort of ID, might actually be either a drop head condition or a regular condition, and in which case we might want to test at this stage whether or not we're not putting a drop head condition into a regular fire seal into a drop head condition. So to actually check that we've got a minimum value above that is important. We can also set an offset. So rather than tracing up the wall directly, we can actually then give it, say, a small offset to detect any kind of components. And we've also got the distance to the bottom of the compartmentation as well, and we've called this fire seal position. So what this does here is it will go away and it will find the positions of those elements. So we've got an issue with the side of this fire seal with this internal wall here. What we're saying is we require 300 millimeters around the outside of that, and you can see it's finding this wall. So this is not deemed appropriate by the manufacturer as far as its physical location within the wall structure. And then on top of that, we're not really conforming to that sort of header condition, basically, where we might be looking at whether it's a drop head condition. So you see this is 374.5 rather than the 400 millimeters. So the idea here is that you can then, if you have put those fire seals in and you're specifying that they are either drop head or regular, you can then obviously then check to see whether or not that it would still conform to them. And that's the idea behind the position within the wall sort of type of checks. So we'll move on to the next one. Let me just take that off so it isn't highlighted in the same way. The next one really looks at the fire stopping opening and thicknesses. So where we move on now to a situation where we have actually got a fire stopping component that's in the wall, and we might have an opening that's there. What we want to ensure is that the edges of the fire seal touch perfectly the edges of the opening itself, so there's no gaps between it. So it's 0 millimeters basically, so it's fully enclosed within that area. Just to mention, which I forgot to mention to do with the distance rule, Solibri actually has a clash detection rule basically, and it has a distance kind of functionality. What we've actually done with our distance rule, when you saw those cable carriers and things like that, which had a distance sort of value, or the distances between the services there, we are only checking the distance, or when we're measuring in elements, we're only checking the distance within the fire seal component itself. So we're narrowing that down to the bit that we're focusing on rather than distances across the whole element. So there's a level of intelligence there as well that it's carrying out. So this rule is checking to see whether or not it touches the edge of the actual fire seal correctly, and also it goes away and checks that the fire seal thickness is at least the thickness of the wall, so that it's not narrower than the wall itself. This one's not positioned in the wall correctly, so it's detecting that it's not correctly correctly positioned within the wall. So that's really the fire stopping opening and thickness functionality. We had a message, so just show you, we actually look at the data that comes into our Solibri. I'm trying to think of the name of it now. You'll have to help me out, Ken, here. The online web portal that we use for
Solibri
customers.
Society.
Solibri Society. I just had a bit of a blank moment there. So on Solibri Society, we had a customer that basically was asking us whether or not that we could do certain things to do with materiality usage, and we picked it up from a support call as well. And what they wanted to actually generate is sort of net to gross areas of those components. So this rule basically will go away and actually tell us sort of, we haven't done anything with it at the moment, but theoretically we can then start looking at sort of material optimization or something like that. But the idea behind this is if we select this first component here, what you can see is two dotted lines on the screen. So you can see the gross area here, and we can see the net area, and we can report those. So we've got the gross areas, which is 0.159, and the net area 0.077. Okay, what we need to do, we haven't done this yet, is make that available so that you can actually push it through into an ITO. So you can list those. And I suppose then there's a possibility of looking at the cutouts and seeing whether or not you could optimize the usage of the materiality there. To give sort of advice on that point of view. I mean, obviously the ablative back kind of materiality is going to be quite expensive. So and on a large project, the amount of material you might use, to have some kind of optimization might be a good idea. But first of all, the first part of this was to work out the gross to net areas on that rule. So that will do that for you in the rule itself. On top of that, we also have a clearance rule. So the position rule is all about the manufacturer approved sort of position within a wall, but that doesn't address the situation to do with actually physically installing these components. So the clearance rule is all about looking at the clearance that you might need for a person to physically install it. So again, we've got all our same details we're putting in here in our fire stopping ID, and we actually have this functionality say whether or not we've got inaccessible spaces. So we can actually specify whether or not you would either be able to. So if you've got an inaccessible space, what we're actually saying here is that it should be a single-sided installation rather than the double-sided installation. And in which case, if we've got a space that basically means that we can't install it from the other side, then basically only checks one side of that for the spatial requirements for a person to get in there to do that. And we can check for the distance for the relevant spaces here. So the whole idea of that one is what it does is it goes through, and I'll just take this example here. You can see that it puts a box around we can define the size of the box above it and to the sides of it and the one in front of it, and we can also set an offset as well. So it might be that you might want to position or change the sizes of these boxes, and again that's the position on the walls. We can then go to, let's just clearance. Okay, so the clearance here again for the fire seals, we can actually set a side offset. So if we set that to 300 millimeters, we can set a top offset or a depth of it, and we can put a bottom tolerances, so we can actually move away. So we might have pipes that go down the wall in front of it, but you'd still be able to get a step ladder in there. So maybe if you've got, say, 300 mil in front of it, you'd still be able to reach over that. And then we've got a bottom depth here, which we can actually also then set to, say, 300 mil here. So by changing the values in the spreadsheet and resaving the spreadsheet, we can then make sure the rule actually reruns. You can do that by just making sure once they've run, you can just change one of the parameters and change it back, and it will rerun that rule for us. And we'll see that the definition of that it's now picking up the fact that we've got a wall that's clashing with the sizes of those boxes. And you can see here that the box, we've moved it away so that if there was services coming out and then downwards, then you would still have this access area here that you might want to put a depth, much bigger depth in here. So obviously you get a pair of step ladders or something like that. But the idea here is to get an idea of whether or not it would be easy to install or not. And that's what the clearance rule is all about. And then finally, for our fire stopping rules, we actually have a support rule. Now, the support rule you again uses a further sort of tab here, and we've obviously got those fire seal clearance for floors as well in the same way. But the wall support basically goes through and checks the supporting wall construction. So it requires you to look at the fire seal IDs and the types of fire seals we've got, and what, generally speaking, are allowed in those fire seals. So again, looking at manufacturer's information, configuring it for their typical details and the type of services that are allowed in there. And then down here, then we can then start putting in requirements that are needed for that fire seal. So the fire seal can be in a wall with a minimum or maximum value, basically between these two values. The idea behind this is that you can set the size of wall types that they must be contained within. We can also set the fire rating, minimum and maximum fire ratings. It also goes through and actually checks that we haven't got fire ratings that say 59 or 56, so instead of 60 or 30 or whatever. So the idea is you've got a maximum and minimum range, and it will obviously detect things that are over that as well. We've also can check the acoustic the acoustic rating, and also the deflection movement, again by putting in the values that are required by that particular ID, that seal itself. Again, over here, we then can specify whether it's double or single-sided installation. So we've got a D or an S for that. So they're the two values you can put in. And we've also got the regular and drop head sort of detail for that type of fire seal. So again, it will go away and check that same condition in the same rule. And then we can then put in our distance to the top compartmentation, so we can actually see whether or not it would actually pass or fail with an offset like before. And then we can also specify whether this is a single or multiple service fire seal type, basically. So it goes through and it will then check all these conditions. The rule itself uses the values in the sheet there. What we do is we specify again the walls here, and then we can then specify the parameters that we're going to use for, say, the thickness of the wall. So in this case here, we use the base quantities and the width value. Again, fire ratings. So what we're actually doing is picking the actual properties away from the walls. Now, I haven't given it a deflection movement value, and we'll see what goes wrong there. We've also got the services that are being specified, the fire seals that are being specified. If we go down a bit further, we've got the fire seal ID, and then we have our inaccessible spaces. So if we have so what this is doing in the background is if you put in a single-sided, so a double-sided item here, then it will go away and check that actually both sides of that are able to be accessed to be able to install that fire seal. So what we're doing is we're specifying which spaces are inaccessible, and if we have a value in there that's inaccessible, then it will then highlight it for you, check either side of it. Now we can also set the space range that it projects from the fire seal into the actual room either side to search for a space, basically. And in this case here, the obstructions that I might want to use for the drop head kind of condition that's in there, I can put in what elements that I don't. So in this case here, I'm saying anything from the architectural and structural model, but exclude any spaces, because I don't want it clashing with spaces. So that rule then goes through, and in this case here, you can see that it gives us sort of 5 types of issues to do with this rule. So we've got the acoustic rating that's not being conformed to, and again, look, it tells you the fire seal ID, which is the individual instance. It tells us the fire seal type, tells you what service is going through it, tells you what the minimum and maximum values you put in there are, and then the actual acoustic rating. So it's kind of, okay, so it might be more than it or less than it, but it has to fall between the two values, and it will tell you why it's failed. Again, the fire rating, very similar in this case here. We just put the values in at 90, and it's saying the actual rating is 120. This was the single or double-sided. So in this case here, you can see on the model itself that we've got it's required whether it's single or double-sided. This one's a double-sided because it was a D. The actual single or double-sided, we found out that it's single-sided. And what we then highlight on one side, on the A side of it, is in yellow is the relevant spaces that would make it obviously a inaccessible space. So in this case here, the service access space here is being coloured in magenta, which is actually showing us that, okay, you could install it from this side, you couldn't actually get on the other side. And as this definition of this fire seal is a double-sided installation, then we're able to track whether or not that it can pick that up as well. Again, wall width, checking the wall width actually is between the relevant values or what it's designed to actually work with, and then obviously the deflection, which is saying unspecified value because we've not got a value in there. So that's basically how that works with the fire stopping support rule. And that's our rule set as it is at the moment. We will generate one more rule, which will generate a list of all of the fire seals, the services that go through them, and the data to do with the supporting wall construction, so that we can actually create a complete breakdown of that information as part of for delivery as part of the golden thread data. But I hope that that's given you an insight to the substantial amount of work that's gone into that, and I have to thank the bodies that have been involved, especially Langer Rock in this case here, in helping us to define these rules as you see on screen. The original release will be a beta release, as it will push out, and we expect that by a lot of people testing this and seeing how it works, that we might have a bit of extra work to do here. But essentially, that's our fire stopping rules. So I'll hand back over to Ken and look at any kind of Q&A session.
Yeah, there's a couple of questions. Let me just make myself the presenter again. And it should switch over. There we go. So not as much to show on screen, but just to have something on screen. So yeah, there's a couple of questions. One quite techie, which I'll leave to you, and the other one is just somebody asking about being able to define this. So I think following up what Simon just said there, we haven't released this publicly yet. The plan, we'll show you some dates in a second, but the plan is to release it fairly soon as a beta release, with a final release going out a couple of months after that. So the plan at the moment is this will go through as an extension on the Solution Center. So you'll be able to buy the free licenses in effect on the Solution Center, and then those can be assigned to users to enable them to install it inside the appropriate version of Solibri Office. So it needs to be 9.12, 10 or later. So yeah, there's a couple of other questions just popping up now, Simon, that'll
Okay, I can see one of them there, but it says how does the work in the BWIC, if the BWIC are modelled as an extruded route that goes through several walls rather than just individual hole through the wall. I think that we may have a few issues related to whether or not it will detect those other walls when we're looking at the position. We would have to test that, but it should actually cope with the with the service distances correctly. It's a very good question, and it would be one that if there's any models that we actually have there, we'd be very interested in just getting an example model where there are multiple walls that the BWIC goes through. So yeah, thank you for the question. If you want to contact us, and we can actually take that into account and see whether or not one, it may actually not be a problem, but if it is, then we need to then update that so that it copes with those scenarios. Okay.
Okay. Can you see the questions? Do you want me to?
Yeah, I'm just looking through them now. So what is Solibri Society? Okay. Yeah, so the PDF that I showed, when you say is it available, it's available from the Association for Specialist Fire Protection. So if you just type in the name of the actual of the document, then you should be able to. It's pretty easy to find on the web, but we can post on the response to this session where you go and find that document. So it's not a problem. Okay. Okay, good question. What's the
There's a
difference
couple of
between?
things. So,
I've got here.
on you
What's
go.
the
I
difference?
thought I was going to be
Yeah.
general stuff.
Okay, what's the difference between fire stopping and fireproofing? As far as I understand, the fire stopping is really all about the making sure that the containment walls that have a certain fire rating are where service penetrations go through that are we're keeping or upholding the same level of fire protection for those key areas within the building. I'm not quite sure fireproofing, as fireproofing can be probably applied to multiple sort of scenarios, but the key part in the UK really is down to the fact that obviously, as part of the Building Safety Bill, that's obviously gone through the Building Safety Act or whatever. Every building that is a multiple occupancy building, which has floor levels that are over 18 meters, obviously you have to provide this information. And the key part is that as it goes down as part of the golden thread information, as responsibilities for this data, if there's ever a horrible repetition of, and let's God hope there isn't one of the Grenfell incident, then people will be held accountable for this information. But also, owner occupiers and owners of the buildings, basically, if they modify these, will have to uphold that level of information as well. So. One thing that we are working with is we are working very closely with another product called Immerso, and these sets of rules at the moment are testing the design condition. What's really impressive is that we can then take these rules and take the actual physical installation of these services in the actual building model and the position of them. Obviously, we can pull them back inside Solibri from the actual IFC file based upon the point cloud data that gets scanned, and we can then test the actual location of these services and see whether or not they still conform. So we're all aware that on the site that a pipe might be cut a little bit shorter, and all of a sudden that the distances that were designed as part of an approved definition might not actually in reality or in practice, as in what's installed, actually still conform. And I'd imagine that at that point there, if there is any kind of problems with an incident, the manufacturer may be called in, and actually they would actually analyse the positions of these components. And if they don't conform, then the manufacturer won't indemnify it either. So it's quite important that we are actually checking this from an installation point of view as well. Okay, there's some more generic questions there. Can travel distances be measured between apartment doors? Yeah, within Solibri there's an egress rule which we can actually use to out of the box, basically one of our rule templates that you can set up, and you can set those relevant sort of doors up and the staircase locations and everything else, and you can measure between them, and it will then do a route between them specified on distances. Okay, so yeah, that was to say thanks for the link to the, and I'll just go grab that before the end of the session. Would the Excel book be available when? Yes, so the Excel book will definitely be available as an example, along with a model example, so that you can actually see how it works, and it gives you a starting point really. Each of the rules will also be identified as far as which tabs relate to which rules in the Excel spreadsheet. It doesn't mean to say that then you have to have the same Excel spreadsheet. So, for instance, you could split that spreadsheet down into multiple Excel books, and with just individual tabs in them, as long as the rule can see that tab from a different location. It means that different parties could actually carry out the definition of those individual sheets rather than actually having it as one combined sheet. So that's the way it would work. Okay. I think that's answered most of them, other than pasting the link in for the fire stopping penetrations guide.
Yeah, I answered a couple of those while you were talking away there.
Okay.
So I think we've got everything, unless anybody has any other questions. We should do is actually go to the next slide, because it has the important dates on it.
Okay.
So The final slide's a thank you, but it's also got a little save the dates area, and we've got a few things coming up. So in a couple of weeks, we're doing a general intro to Solibri, just purely a general overview of the workflow that we go through in a typical project. Then we're going to be looking at the first look at the stud opening rule. So this will be a first solution that will be launched and made available publicly. That particular rule uses some pseudo components to check the studs around openings, as the name suggests. So studs typically aren't modelled at an early stage of a project. They might never be modelled. So what we want to do is check for any services that clash against those studs around the openings, and we can check the sides, the top, we can extend down, we can add in tolerances, all sorts of bits. It's a very, very simple rule, but something that without the rule would be almost impossible to do because these components just don't exist there. So that's coming up in is that 3 weeks time roughly. And then in terms of fire stopping, this solution that we've been looking at today, the beta release, we've planned that for the 1st of September to get the documentation and everything ready. I think we've already said that it will go through the Solution Centre, and the aim is after that initial beta release, the full final version, or almost final version, will be a couple of months after that. The aim at the moment is 1st of November, but that is the plan, so stay tuned. And if you have any questions, just fire them through to sales-uk@solibri.com, and we can pick them up from there. Okay, there's a few other questions, but I think it's all okay, I think.
Sorry, I'm just trying to find the. It's not a website that I go to all the time, basically, which is the Association for Fire Protection for the guide. But we will make sure that all the attendees for this presentation will have access to the guide.
What we'll do is we'll post it. We will do a follow-up email that will have a link to the recording and stuff like that. What we'll do is make sure we include that in the follow-up that goes out. Yeah, I'm sure it's not something you refer to every day. Okay, so I guess we'll wrap things up there. So thanks very much for your time and for going through the session. If you do have any follow-ups, as I say, just drop us an email. We will send a follow-up email with a link to the recording and the link that Simon's discussed. But otherwise, thanks again, and hopefully we'll see you in a couple of weeks' time at the next events that are coming up.
Okay, thank you, everybody.
Okay, cheers.
Thanks. Bye-bye.
Bye.